In today's video, we are going to talk about what exactly the absolute pressure is and what is the gauge pressure. To understand this, let us consider a tank filled with water. Now we consider an imaginary cylinder present inside this water, in this water tank. Let us say y be the height of the water tank and base of the imaginary cylinder at y1 and top of the imaginary cylinder is at y2. So y2 minus y1 equals to h. This h is nothing but height of the imaginary cylinder. Now we consider two forces. One is F1, another is F2. The force F1 is acting in downward direction. It is acting in the downward direction at the top surface. This is the top surface. And force F2 is acting in upward direction at the bottom surface. So we got two forces. One is the F1, another is the F2. They are vector quantities. There is the water above the imaginary cylinder. Here is the water above the imaginary cylinder. Similarly, there is a water below the imaginary cylinder. Therefore, F1, the force F1 is nothing but force due to water, force due to water, due to weight of water above imaginary cylinder. And F2 force due to weight of water below the imaginary cylinder. Since entire cylinder is filled with water. Let m be the mass of this water enclosed inside this imaginary cylinder. So weight of the water will act in the downward direction. So mg equals to weight of water in imaginary cylinder. Direction of this weight is in the downward direction. Since this imaginary cylinder is neither moving upward nor moving in the downward direction, it is not at all moving. So cylinder is in static equilibrium. So for static equilibrium, total downward forces is equals to total upward forces. So it implies total downward forces, that is F1 plus mg, and total upward forces equals to F2. So F1 plus mg equals to F2. Let A be the cross section. This is the cross section of the imaginary cylinder. So A equals to cross section of imaginary cylinder. And we know that pressure equals to force upon area. So implies force equals to pressure multiplied by area. Now pressure at the top surface of the cylinder is P1 due to the water, and pressure at the bottom surface is P2. Therefore, F2 can be written as P2 multiplied by area cross section of the cylinder, and F1 equals to P1 multiplied by area of cross section of the cylinder. Since mass equals to density into volume, here we had considered the cylinder and we had assumed that m is the mass of water in the cylinder. So formula for mass is density into volume. Let rho be the density of water. Since volume equals to product of cross section multiplied by height. Cross section we have taken A, height equals to h. Therefore volume equals to A into h. Therefore now mass of water inside the cylinder m equals to density multiplied by volume. So rho A h. From this figure h equals to y2 minus y1. Therefore m equals to rho A, and in place of h you can write down y2 minus y1. Now considering only magnitudes and rewriting this expression, that is, you can write it as a F2 equals to F1 plus mg. Under static equilibrium, force F2 equals to F1 plus mg, where F2 is nothing but P2 multiplied by A and F1 nothing but P1 multiplied by A plus m value nothing but rho A y2 minus y1 multiplied by g. Now in RHS, taking A common and cancelling both sides, so we get P2 equals to P1 plus rho, this is rho, multiplied by y2 minus y1 multiplied by g. From this equation, one thing is clear, that P2 does not depend upon area of cross section. So imaginary cylinder may be very big or may be very small in cross section. It doesn't affect in calculation of pressure P1 and P2. So they are independent of area of cross section. Now we can modify this equation to understand absolute pressure and gauge pressure. Now instead of considering imaginary cylinder, now we consider the entire container, and let us say the height of the liquid, height of the water in entire container equals to h. H is the height of the liquid column. Now we are generalizing. First we had taken the support of imaginary cylinder. Now after considering imaginary cylinder we got expression. Now we are generalizing this expression. So now we consider height of the water in the container, water tank, is equals to h, and the pressure at the open surface of this container, at the open surface of liquid container, we consider the pressure P1 equals to P naught, that is atmospheric pressure, and the top surface of the liquid at zero depth, this is the depth of the water, so zero depth, and bottom of the container, this is the bottom of the container at the depth of minus h, because it is below the top surface, so we do consider negative, so y1 equals to minus h, and at the bottom of the surface the pressure due to liquid we do consider as a P2 equals to P. At the bottom of the container the pressure due to liquid due to the water equals to P2 equals to P. So the above equation gets modified. Now in place of P2 write down P, in place of P1 we write down P naught, that is atmospheric pressure, plus rho, and y2 equals to 0 depth minus, and y1 equals to minus h depth, negative depth, because it is going below the water level, therefore we have taken minus h. Therefore we get P equals to P naught plus rho multiplied by h into g, that is we get here P equals to P naught plus h rho g. This P value we so obtained is nothing but called as a absolute pressure, and P naught is the atmospheric pressure. H rho g is nothing but pressure due to liquid at depth h. Here is a liquid, we had taken water, but we can have any other liquid. So H rho g equals to pressure due to liquid at depth h. So we have the three things now. One is the P, another is the P naught, another is the H rho g, where P nothing but called absolute pressure. Now this equation can be written as P minus P naught equals to H rho g. So P minus P naught nothing but difference of absolute pressure and atmospheric pressure. P minus P naught, it is the difference of absolute pressure and atmospheric pressure. In general, this difference of absolute pressure and atmospheric pressure is called as a gauge pressure. So in this video we have understood what exactly the absolute pressure and what is the gauge pressure, and what exactly the difference between the absolute pressure and gauge pressure. So difference of absolute pressure and atmospheric pressure is equals to gauge pressure. This is very important concept in physics. So that's all in this video. Meet you again with next topic. If you think you are benefited by this video, then please write down your comments in the comment box and like the video, share the video with your friends so that more and more students will get benefited by this video. Meet you again with next topic. Till then, wish you good luck. All the best.